Here, Maxwell equation for free space. Maxwell's equation for free space. These are the Maxwell equations. Now we have to derive those Maxwell equations for free space. Now here, in case of free space point of view, we have one condition is rho v equal to 0. Rho v equal to, that means charge density, rho v is equal to 0 and sigma value is equal to 0. Rho v is equal to 0 and sigma is equal to 0. By depending on these two conditions, our previous Maxwell equations are modified. That means here free space means there is no charge. So the value of rho v is equal to 0 and sigma is equal to 0. Just simply those two values we are substituting. Now look at here. These are the Maxwell equations in final forms. Maxwell equations in final form that we have seen in our last point. Now I am substituting our conditions, that is for free space we have already assumed rho v equal to 0 and sigma equal to 0 for free space point of view. Now I am substituting these two conditions in these equations. So then those will become the Maxwell equation for free space. Just look at here carefully. These are the Maxwell equations final forms. These are the Maxwell equations final forms. Now for these final forms I am converting into free space point of view. Now these will become Maxwell equations for free space. In case of free space, rho v is equal to 0 and sigma equal to 0. Now look at here, the first one, this one. That means del dot d bar equal to, here it is rho v. The value of rho v here is 0. So it will become 0. And this integral form, this form will be written as, look at here, surface integral of d bar dot ds bar equal to volume integral of rho v. Here it is rho v. So the value of rho v is 0 dv. Then it will become surface integral of d bar dot ds bar is equal to 0. It is differential form. It is integral form. That is the first equation. Del dot d bar equal to 0. Then surface integral of d bar dot ds bar equal to 0. It is the differential form. It is the integral form. Now look at the second equation. Del dot b bar equal to 0. Del dot b bar equal to 0. Here there is no values to substitute. So as it is, keep it as it is. And here its integral form is surface integral of b bar dot ds bar equal to 0. This one I am writing here. Now the third equation, look at here the third equation. Del cross E bar equal to minus dou B bar by dou T. Del cross E bar equal to minus dou B bar by dou T. No substitution is required because rho V value 0 and sigma value 0. So there is no two values will be present. And here integral form will be as it is. That is line integral of E bar dot dl bar is equal to minus dou by dou T into this one. This one I am writing as it is. Surface integral of B bar dot ds bar. And look at here the fourth one. Del cross H bar equal to J bar plus dou D bar by dou T. Here we have to substitute J bar. Here it is sigma. So it will become, here it is sigma. So simply here J bar is equal to sigma E bar. Here sigma value is 0 into E bar, that equal to 0 in last case. Now I am substituting J bar value 0 in this equation. So del cross H bar equal to 0 plus dou D bar by dou T. It is the differential form. And similarly this one, its integral form is line integral of H bar dot dl bar equal to surface integral of J bar value 0 again, dou d bar by dou t dot ds bar. It is the integral form. These are the Maxwell equations for free space. Maxwell equations for free space.